Every aspiring mushroom farmer hits the same wall. They watch a few videos, get excited about the margins, and then see the lab. Flow hoods costing from $400 to $2,000. Pressure cookers, agar plates, sterile grain transfers that fail 60% of the time for beginners. The excitement dies right there. What those videos never mention is that thousands of profitable small mushroom farms operate without any of that equipment. They buy spawn. They pasteurize substrate using methods that require nothing more than a bucket, water, and hydrated lime. They fruit mushrooms in a Martha tent that costs $80. And they sell every pound at the same price as any lab-equipped farm. The hard part is real. The requirement to do it yourself is not. This video covers the complete no-lab production system, the costs, the margins, and the exact point where adding a lab finally makes financial sense. The hard part of mushroom farming is not growing mushrooms. It is producing the spawn that starts the process. Spawn production begins with isolating a clean mushroom culture on agar media inside a sterile environment. That requires a laminar flow hood, a piece of laboratory equipment that pushes filtered air across a work surface to prevent airborne contaminants from landing on exposed cultures. A decent flow hood costs $400 to $2,000. A pressure cooker large enough to sterilize grain bags runs $60 to $300. Petri dishes, agar powder, scalpels, parafilm, and alcohol add another $50 to $100 in recurring supplies. Clean cultures isolated on agar are transferred to sterilized grain, typically rye or millet, inside sealed bags or jars. Every step must happen under sterile conditions. A single mold spore landing on the grain during transfer contaminates the entire batch. Beginners lose 30 to 60% of their spawn batches to contamination in the first months of learning. That is not a failure of intelligence. It is the nature of working with microscopic organisms in an environment that is inherently hostile to sterility. The learning curve is steep and the feedback loop is slow. A contaminated batch does not reveal itself for days or weeks after the mistake was made. YouTube and online courses present this process as the mandatory starting point. Aspiring growers see the equipment, the technique, and the failure rate, and a significant percentage of them conclude the barrier is too high. They never fruit a single block. Most people who abandon mushroom farming quit at this stage, not because growing mushrooms is hard, because producing spawn is hard. The distinction matters enormously, and profitable no-lab farms are built on it. Commercial grain spawn from a reputable supplier costs $15 to $30 per bag. Each bag inoculates 5 to 10 fruiting blocks. That puts the spawn cost per block at $1.50 to $6. The math makes the decision straightforward for any grower whose goal is revenue rather than laboratory mastery. Commercial spawn suppliers produce at industrial scale inside purpose-built clean rooms, with contamination rates under 1%. A beginner producing spawn at home in a still air box or improvised flow hood loses 30 to 60% of batches while learning. The commercial product is cleaner, more vigorous, and more reliable than anything a new grower can produce for the first 6 to 12 months of practice. Buying it eliminates the flow hood, the pressure cooker, the agar supplies, the grain sterilization process, the sterile technique training, and the months of failed batches that precede competency. The total equipment savings range from $700 to $3,000 depending on setup quality. The argument against buying spawn is that it creates a recurring cost. That is true. It is also how every successful business operates. Restaurants buy ingredients. Builders buy lumber. Mushroom farms buy spawn. The revenue is made in fruiting and selling mushrooms, not in producing spawn. Every hour a small grower spends on lab work is an hour not spent on substrate preparation, fruiting management, harvesting, and sales. Those are the activities that generate income. Profitable small farms treat spawn as a raw material input, buy the best quality available from specialists, and focus every available hour on the value-added process that actually puts money in their hands. Lab-based mushroom farming relies on sterilization. killing every living organism in the substrate so that only the introduced mushroom culture can grow. No lab farming relies on pasteurization, reducing the competing organism population enough that vigorous mushroom mycelium outcompetes whatever survives. The distinction is critical because pasteurization requires no sterile environment, no pressure cooker, and no laboratory technique. It happens in a bucket, a stock pot, or a cooler. Cold water lime pasteurization is the simplest method available. Chopped straw is submerged in water mixed with hydrated lime, calcium hydroxide, for 18 to 24 hours. The alkaline environment eliminates competing molds and bacteria without any heat source. Cost per batch is pennies. The setup is a container large enough to hold the straw and water, nothing else. Heat pasteurization submerges chopped straw or sawdust in water held at 160 to 180 degrees Fahrenheit for 60 to 90 minutes. A large stock pot on a propane burner or an insulated cooler filled with hot water handles the process. Hardwood fuel pellets available at any hardware store simplify the method further. Boiling water poured over the pellets pasteurizes and hydrates the substrate simultaneously in a single step. After pasteurization, cooled substrate is mixed with purchased grain spawn at a ratio of 10 to 20% spawn by weight, packed into grow bags with filter patches, and sealed. The entire process from dry substrate to inoculated bag takes 2 to 3 hours per batch. No pressure cooker, no autoclave, no sterile room. Contamination rates with properly executed pasteurization run under 5% for experienced growers. Farms producing hundreds of blocks per week use these exact techniques at commercial scale. A no-lab farm running pasteurized substrate and purchased spawn produces the same mushrooms at the same quality with the same yield per block as a lab-equipped operation. The process from inoculation forward is identical regardless of how the spawn was made. Inoculated bags go into a dark, warm incubation space held between 68 to 75 degrees Fahrenheit. Over 2 to 3 weeks, white mycelium colonizes the substrate visibly through the bag walls. Any bag showing green, black, or orange patches is contaminated and gets removed immediately. Fully colonized bags move to the fruiting chamber. A Martha tent, a wire shelving unit wrapped in a clear plastic cover, is the standard small farm setup. Slits are cut in the bags to provide openings for mushroom clusters to emerge. Humidity is held between 85 and 95%. Temperature drops to 55 to 70 degrees depending on species. Fresh air exchange runs 4 to 6 times per hour. 12 hours of indirect light triggers pinning. Pins appear within 3 to 7 days. Harvestable clusters develop within 5 to 10 days after that. Each block produces 2 to 3 flushes spaced 7 to 14 days apart. A single 5-pound block yields 1 to 2 pounds of fresh oyster mushrooms across its full cycle. A Martha tent holding 20 to 40 blocks produces 40 to 100 pounds of fresh mushrooms per month, with staggered inoculation keeping harvests continuous every single week. Buyers at farmers markets and restaurants do not ask how the substrate was prepared. They ask whether the product is fresh, consistent, and available next week. Total startup for a no-lab mushroom farm producing 40 to 100 pounds per month runs $300 to $500. A Martha tent or a wire shelving unit with a plastic cover costs $40 to $80. An ultrasonic humidifier paired with a humidity controller runs $70 to $100 combined. A small fan for fresh air exchange, a light strip for pinning triggers, a spray bottle, and basic sanitation supplies add another $35 to $60. That is the complete infrastructure. Recurring costs are where the no-lab advantage becomes clear. Substrate materials, straw bales, or hardwood fuel pellets cost $5 to $15 per batch. Grow bags run 20 to 40 cents each. Spawn is the primary recurring expense at $15 to $30 per bag, inoculating 5 to 10 blocks. Total cost per fruiting block, including substrate, spawn, bag, and incidentals, lands between $2.50 and $8. Each block produces 1 to 2 pounds of mushrooms, selling at $8 to $16 per pound retail. Cost to produce 1 pound sits between $1.50 and $5. The margin is 3 to 10 times the input cost. Now add up what the no-lab approach does not cost. No flow hood at $400 to $2,000. No pressure cooker at $60 to $300. No agar supplies at $50 to $100. No sterilizable grain at $20 to $40 per batch. No months of trial and error producing contaminated spawn that generates zero revenue. The money not spent on lab equipment is money available for more substrate, more spawn, and more fruiting capacity. That is where revenue comes from. Every dollar redirected from the lab to the fruiting room earns a return. Every dollar spent on a flow hood before the first mushroom is sold does not. No buyer, restaurant chef, farmer's market customer, or wholesale distributor has ever asked a mushroom farmer whether their substrate was pasteurized or sterilized. The market does not distinguish between production methods. It distinguishes between fresh and stale, consistent and unreliable, available and out of stock. A no-lab farm selling at a Saturday farmer's market stands next to a lab-equipped farm, and both sell oyster mushrooms at $8 to $16 per pound. Both sell lion's mane at $12 to $20 per pound. The customer reaches for whichever product looks freshest. The substrate preparation method behind that product is invisible. Restaurant direct sales follow the same pattern. Chefs want 10 to 20 pounds per week, delivered reliably at $6 to $12 per pound wholesale. 3 to 5 restaurant accounts absorb the entire output of a single Martha tent. The relationship is built on consistency and freshness, not on whether the grower owns a flow hood. Dried mushrooms sold online at $20 to $40 per ounce for premium dehydrated product reach a national market without any buyer ever seeing the production facility. Grow kits assembled from the same pasteurized substrate and purchased spawn sell for $15 to $30 each, with high margins and strong demand as gifts and educational products. Value-added products extend the revenue further. Mushroom powder, seasoning blends, and lion's mane tincture all command premium pricing from simple processing. The competitive advantage at small scale is not lab capability. It is showing up every week with a fresh, consistent product and building the buyer relationships that turn first-time customers into standing orders. No lab farms and lab-equipped farms compete on identical terms in every sales channel. The playing field is level. There is a specific production volume at which producing spawn in-house becomes cheaper than buying it. That line is higher than most aspiring growers assume. At 20 to 50 blocks per month, buying spawn is unquestionably the smarter financial decision. Equipment cost, time investment, contamination losses, and ongoing supply overhead make in-house production more expensive per block than purchasing from a commercial supplier at this scale. At 100 to 200 blocks per month, sustained over 12 or more months, the per-block savings from in-house spawn production begin to offset the lab equipment investment and the hours required to maintain it. The practical threshold for most operations sits at roughly $15,000 to $25,000 in annual spawn spending. Below that number, buying is cheaper. Above it, lab investment starts to pay back. Most profitable small farms operate below that threshold for 1 to 3 years before the lab question becomes financially relevant. The smart sequence is clear. Generate revenue first. Build capability later. Add the lab only when the math justifies the investment. The risks of no lab production are real and manageable. Contamination from inadequate pasteurization is the most common failure. Water temperature that is too low or soak time that is too short leaves competing organisms alive in the substrate. Substrate moisture content matters. If it is too wet, colonization stalls. If it is too dry, mycelium cannot spread. Spawn quality varies between suppliers. Unreliable spawn produces unreliable results regardless of how well the substrate was prepared. Sourcing from proven, reviewed suppliers with consistent track records is not optional. Harvesting too late allows spore drop that shortens shelf life and damages visual appeal at the point of sale. Every one of these risks has a specific, learnable solution. None of them require a lab to fix. Week 1. Order grain spawn from a reputable supplier. Buy straw bales or hardwood fuel pellets. Set up the Martha tent with a humidifier and controller. Total spend, $300 to $500. Week 2, pasteurize substrate using cold water lime or the heat method. Inoculate the first batch of 10 to 20 blocks and place them in incubation. Week 4 to week 5, move fully colonized blocks to the fruiting chamber and introduce fruiting conditions. Week 5 to week 6, first harvest. Fresh specialty mushrooms ready to sell. 6 weeks from ordering supplies to holding sellable product. No lab, no flow hood, no agar plates, no months of sterile technique practice, no $700 to $3,000 in equipment sitting idle while the learning curve eats through batch after batch of contaminated grain. The no-lab approach is not a shortcut that sacrifices quality. It is the business-smart sequence that every profitable small farm follows, whether they talk about it publicly or not. Generate revenue first. Build skills and customer relationships on real production. Add lab capability later, only when the annual spawn bill crosses the threshold where in-house production genuinely saves money. The lab is not the hard part. Starting is the hard part. The no-lab approach removes the single biggest excuse most people had for never doing it. Subscribe for more practical mushroom farming strategies. Drop a comment and tell us whether you stalled at the lab stage or whether this changed your plan.